My name is Sharon Frost, and this is my video essay for Chapter 9 in Anatomy and Physiology lecture. I'm going to summarize the steps for muscle contraction. First, nerve impulses reach the axon terminal of the motor neuron. A neurotransmitter called acetylcholine, or choline, I'm not sure if I'm saying that quite right, is released from the terminal by exocytosis, and it travels across the synaptic cleft and binds to receptors on the motor end plate of the sarcolemma. This opens the ion channels and allows sodium into the muscle fiber and potassium out of the muscle fiber, which this is what causes the end plate potential. Now, the end plate potential also causes a wave of depolarization that spreads to the sarcolemma. This triggers the action potential. Now, the action potential travels down the T tubules and it causes the voltage-sensitive tubule proteins to change their shape. And what this does is when it changes the shape, it opens the calcium release channels in the sarcoplasmic reticulum. The calcium that's been released, now it's going to bind to the troponin, and it removes the blocking action of the tropomyosin on the thin filament. All right, this is going to expose the myosin binding sites in the actin. Now, on the thick filament, there are myosin heads that have been cocked or energized by hydrolyzing a molecule of ADP, and it splits it down into ADP and P. And like I said, that's gonna cock the head of the myosin head. And the myosin head can then attach to the actin on the thin filament, forming a cross bridge. So you have the myosin head attaching to the actin, which is on the thin filament. All right. At this point, the ADP and P are released, which causes a power stroke. So basically what's going to happen is that myosin head is going to pivot and bend, pulling that thin filament towards the M line, which is towards the center of a sarcomere. All right. And then an ATP molecule comes and it attaches to this myosin head, and the myosin head is going to release from that filament. And it's not going to be cocked, it's just going to be sitting there. But then the myosin head will hydrolyze the ADP again, the ATP, down to ADP and P again, which is going to re-energize and recock that myosin head, ready to form another cross bridge. And that is the extent of where I'm going to go with this muscle contraction video.